logarithm function, right? And you've been graphing it and looking at its properties. Today we are going to look a little bit more closely at what logarithm actually represents and kind of get more familiar with it, more comfortable with this. We will evaluate logarithm and kind of go back and forth between exponential form and logarithmic form. So as we already learned, the logarithms are the inverses of an exponent, or logarithm is the inverse of the exponent. This means that to convert exponent to logarithm and vice versa, you switch argument and answer. Right? That's how we go between the function and its inverse. We switch argument and the answer. Logarithm is written as this, which is red log base b of x. And we see this notation, we say logarithm base b of x. Okay. So, say again? Oh, that's just like what you said. So let's look at the example. If I have an exponential function y equals 2 to the power of x, the inverse is y equals log base 2 of x. So if I'm looking at my exponential function and I'm looking at the xy table, right? If x is 0, then my y is what? I'm looking at my exponential function. Y equals 2 to the power of x. So if my x is 0, then my y is what?
1.
1, which is 2 to the power of 0, right? If my x is 1, then my y is what?
2.
2, which is just 2 to the power of 1. If my x is, let's say, 3, then my y is what?
8.
8, which is 2 to the power of 3.
Wait, so it's just...
I'm just creating the xy table for my exponential
No,
function.
I'm just trying to understand a little bit better. So, whatever the number is, you just put it to the power of 2 in this case?
No, I'm taking that number, I'm taking 2 to the power of that number, right? Because that's my exponential function. So if I'm looking now at the inverse function, the log function, I would have to switch x and y places, correct? So instead of 0, 1, I have 1, 0. Instead of 1, 2, I have 2, 1. And instead of 3, 8, my point becomes 8, 3, correct? So switching x and y as we did before for the inverses. Already, Isaiah, just wait a little, maybe till the here, okay? So if I'm just looking at one of these points. So let's say x equals 3. 2 to the power of 3 equals 8. Yes? So my base of this exponential function is 2. My exponent is 3, and my answer is 8, correct? With the log, we are doing the opposite. So log base 2 of 8 gives me 2. Right? So it's like doing the opposite. I'm doing what's done to 2. It's like multiplication and division are inverse operations. Addition and subtraction are inverse operations, right? They kind of undo each other. The definition of log is just that. It is the opposite or inverse of exponent. And today we'll do a lot of different exercises to kind of get you more comfortable with this. So you can think about a logarithm as it tells what exponent or power is needed to make a certain number. So log base 2 of 8 is the number that I need to take 2 to the power of to get 8, right? So I'm kind of trying to represent 8 in terms of base 2. So 2 to some kind of power will give me 8. Okay? Any questions so far? I know it's a little bit confusing and it's very not familiar, but hopefully after today's lesson it will be easier to comprehend. Okay, so let's look at how we convert from logarithmic and exponential forms. For any base b, log base b of x equals y It's exactly the same. This is called log form, logarithmic form. So this is my log form. And then I can convert it to the exponential form by switching the argument and the answer. Again, when converting, the base must remain the same. But the argument and the answer are different. So you see, I'm keeping the base be the same. And then the argument to the log function becomes the answer of the exponential function. And the answer of the log function becomes the argument to the exponential function. So argument and answer switch places. Argument like input to the function, right? Each function has the argument or input and the answer or output. Yes? X is input or argument, Y is output or answer. Okay, so two more kind of definitions. The common log. The log with the base 10 of X is called the common log. And we write it as just log X. We don't usually write the base when the base equals 10. And we call this log common log. Just as you had the common exponent, remember? Common log. Now the natural log. So what do you think the base for the natural log is? Huh? What is the natural exponent? E, the number E. Remember, the natural means E. So the natural log with the base E, is written as lnx. So instead of log, we use notation ls. And we know that this is log with the base E. We call this log natural. Questions? No questions? Good. So let's practice. Convert from exponent to the logarithmic form. I'm looking at my equation here. I have the exponential form, right? I have 2 to the power of 2 equals 4. What is my base? So I know that the inverse will be logarithm, right? I'm asked to convert to log form. So what is my base?
Log of 2 to the power of
2.
equals 2.
What is my argument for the log? The new argument for the log function?
4.
4, because it used to be the answer for the exponent. And it equals what? 2, right? So the answer and argument change places. So when I'm looking at this log with base 2 of 4, I'm thinking about what number I need so that 2 to that power equals 4. See what's happening? The opposites. Okay, so number 2. I need to convert to log form, so obviously I need some kind of log there. What is the base of my log?
-2.
Base of this
3.
exponential function is what?
3.
3. So log, base 3. Right.
To the power
So
of
log
1/9
base
equals
3.
-2.
What is the argument for the log?
1/9.
1/9. And then what is the answer?
-2.
-2. Questions for everyone except Dylan. Do you understand what we're doing?
Yes.
Except Dylan.
Yes.
I kind of understand it.
No,
I
kind of. Okay. Number 3, Isaiah. I need to convert this to log form. So I need the log, right? What is the base for this exponent? Right here. You don't know what base of the exponent is?
Isn't it?
Isn't it ln?
E, right? It's always number. So it means that the base of my log should be E. What is the answer for this exponential form? 1. So my answer becomes my argument. And what is the argument for my exponential function here?
0.
So that becomes my answer.
Why isn't it
So can we just put ln?
Okay, so because this log has the E as its base, how do we write this kind of log?
ln.
Ln. So Ln of 1 equals 0. That would be my final answer for this.
What does argument mean? What the base
Huh?
is being powered to?
Hmm?
Is that what argument means? Like what the base is being powered to?
Argument of the function is your x for any function, right? If I have a function y equals x squared, then my argument here is x. My answer is y. Correct? So if I'm talking about this kind of function and I say 2 to the power of 2 is 4, my argument is 2, my answer is 4. Input, out. That's all it means. Yes? And the base of this function is the number that is either the base of the log or it's the base of the exponent. And that stays the same. Okay. Questions about this, the first three. Okay. Now we are going to convert back from log to exponential form. Everything stays the same because these are two inverse functions, inverses of each other. I keep the base and I switch the answer and argument.
4 to the power of 2 equals 16.
Yes. Leah, since I need to convert this to exponential form, I need the base of my exponent. What is the base? In number 1 here. What is the base of this log? Leah? I'm looking at number 1. Log base 4 of 16 equals 2. So what is my base? Log base 4 of 16. What is my base? 4. 4 is my base. So 4 is the base. What is the exponent? What is the argument of my exponential function? I need to switch the argument and the answer. Okay, so the argument to log is 16. So now it will become the answer of my exponential function. So the answer of the log is 2. I need to switch them. So 4 to the power of 2 equals 16. Okay, let's do the next one. Log base 2, 1024 equals 10. So the base of this log is 2. So it will be 2 to the power of something. The exponent is the answer of the log function. So 2 to the power of 10 equals 1024. And the last one.
10 to the power of 3 equals.
Yes, because I'm looking at my log here and it doesn't have any base. I know that base is 10. So 10 to the power of what? To the power of 3 equals
1000.
1000. We still can.
Since log didn't have a base, it's 10 already.
Yes,
There's
it's
a
common log,
Okay.
right? Are we clear on this or no?
Yes.
Who is still confused? Leah, Jaden.
It's just a lot of letters and numbers.
So we have like 5 minutes,
4 minutes.
3
4
minutes.
minutes, 3
Three.
minutes.
3 minutes.
So how about we stop here?
Yeah.
And we just make sure.
Okay, Jaden. Okay, so now that we are comfortable converting between the logs and exponential forms, we will be learning how to evaluate logs, right? So remember, the log tells me what exponent is needed to make a number. So when I'm looking at log base 2 of 4, I'm trying to figure out what number do I need so that 2 to that power gives me 4, right? This is how we will do this. So when I need to figure out that number, sometimes it's easy for me to just look at the log and say, oh, that answer is 2. Sometimes it's not. You know, it will take time for you to internalize this new function. So what we will do is, we will say, okay, I have the log, let me convert it to the exponential form first. So here I have log base 2 of 4. So in exponential form, I have 2 to the power of, I don't know what it is, must equal 4. And now this form is a little bit more familiar for me, right? So I can figure out what this question mark is. What is it? What is the question mark here?
2.
2. So my answer would be 2. So log base 2 of 4 equals 2. Right? If it's still difficult to process the log form, bless you, then we want to convert it to exponential form first. Second example, let's do this one together again. So I need to figure out what is the log base 3 of 9. So I'm trying to represent 9 as the 3 to the power of something, right? Either in my head, or if I want to first convert this into exponential form. So my base is 3. The new argument is the question mark equals 9. See, I'm changing the argument and answer. So what would this question mark be? 2. The log base 3 of 9 is 2. We are representing 9 as 3 to the power of 2. Converting the number into the new format in terms of this base number. Okay, log base 10 of 10. What is the answer? Can anyone?
1.
1, right? If I cannot see that, I will say, okay, so that base is 10 to the power of question mark equals 10. What is this question mark? 1. Because 10 to the power of 1 is 10. Very nice. So you do the next one.
I have a question.
Oh, wait, what is this? All right.
I have a question.
Mm-hmm.
What's the negative on the bottom? Is that with a negative or does it not? Should this be a negative?
No, so how do we deal with the negative exponents? Like from numerator to denominator, remember?
Oh, I hate this so
Oh.
much.
Okay, so number 4 is actually a little bit different, right? Let's do this together also. The number 4 and number 5. Sorry, I didn't see this. So here the question mark is the argument or the answer to the log function. The argument to the log function, right? So if I represent this in the exponential form, I have base 2 to the power of what? 3, because I'm switching the argument and answer, right? So the new argument of exponential function is answer of the log function equals question mark.
8.
Yes, and that's 8. We just evaluate the exponent. Questions? So number 5. Let's do number 5 also together. Again, I have the log form here. So I will convert it to exponential form first. What is my base? 10. What is my exponent? Negative 1 equals question mark. So how do we deal with the negative exponents? Who remembers? No.
Don't.
So what if I have x to the power of negative 2? It's 1 over x to the power of 2, right?
Oh, so 1/10.
So if I have negative exponent, it means that I have 1 over the same thing with the positive exponent. So this is just 1 over 10, correct? Negative exponent, we deal with it by switching numerator and denominator and keeping the exponent but making it positive. Okay, you do number 6. So the answer that everybody I think is about to get or already got, 1 over 9. You got different answer.
I know we're making funny jokes here.
Okay, so now of course, we are mature enough, we're like high school, nobody will show us question marks. So on the test or SL or whatever, we will ask you to evaluate the logarithm. This means to find the number that would go on the other side of the equality sign. So log base 13, 169. I need to figure out what it is. 2. Yes, that's true, but if we don't see that yet, right, we are trying to find the number, so 13 to the power of equals 169. Dylan says it's 2. If that's still hard to kind of process just by looking at the log, I first rewrite it as in exponential form. So what is my base? 13, right? That's my base. I don't know what my exponent is, so I'll put like x or question mark equals 169. And since we're
2.
nice, yes, we will give you only good numbers. So this will be 2. So my answer is 2. Yes? Hannah, all good? Yes. She's like, that's too easy. Why are you going too slow? No? Okay. So second one, log base 2 of 32. I'm trying to find the number so that 2 to that power equals 32. And then we just try to guess, right? So what 2 to what power gives me 32? No. 2 to the power of, not multiplied by.
4.
To the power of, right?
No.
So 2 square is 4. 2 cube is 8. 2 4 is 16.
To the power of
2 to
5.
the power of 5 is 32. So my answer is 5. What do you mean? Okay. Let's do one more together and then you'll finish this by yourself. Or this. Yeah.
3.
Okay, let's do number 3.
3.
I'm rewriting first in my exponential form. So what is my base?
9.
9. What is my argument?
3.
I don't know. And my answer should be 7 to 9. So 9 to what power gives me 7 to 9?
3.
Yes, because 9 times 9 is 81, times 9 is 72, 9. So the answer is 3. Okay. I will write the answers for number 4, number 5, and let's talk about number 6. So 4 should be 4. This one should be 2. Check your answers.
It should be.
And now let's talk a little bit about number 6. Isaiah, are we good? Oh, okay. Anyone needs me to talk about number 6? The answer is negative 3.
Negative 3.
Talk about it? Let's talk about it. Okay. So, I will rewrite first in exponential form. So the base is 6 to the power of something equals 1 over 216. Because I see that the answer is less than 1, that should tell me that the exponent is probably negative, right? Because if the exponent is positive, it cannot be less than 1 answer, right? Because it's 636, 1, whatever, 200 something, right? It's growing. But if the exponent is negative, then I get 1 over 6 to the power of that, right? And so I know that my exponent is negative, and now I just need to figure out what number will give me 216. So 6 squared is 36, 6 cubed is 216, right? So it's negative. Kind of need to learn to recognize these situations. Okay, so are we done with number 7?
Yes.
Okay, my answer is negative 1.
That's mine too.
Good. Let's talk about number 8 and number 9. Let's do this together. Even if you've done it, let's check that you've done it the same way that I've done it.
I did.
So if I rewrite this log in exponential form, what would be my base?
2 to the power of
2, and then to the power of something equals what?
2 to the power of 4.
2 to the power of 4. I could have evaluated this, but I don't need to, because it's easy for me to see that my question mark should be what?
4.
4. That would be my answer, because 2 to what power gives me 2 to the power of 4?
4.
Obviously 4, right? There is no other answer. I don't even need to worry about evaluating this. And so what would be the natural log of e to the power of 5?
E to the power of 6 to the power.
Okay, so let's rewrite this in exponential form. What is my base?
E.
E
the
to
power
what
of
power equals?
E to the 5.
So what is my answer?
5.
5.
Wait, what?
My base for natural log is E. So when I'm converting from natural log to exponential form, I have E to the power of something equal. And now the answer for it should be the argument to log, which is E to the power of 5. Yes? Isaiah, are we good? The argument to this natural log function is whatever is in, the input for
After
ln,
ln.
E to the power of 5.
So the argument is whatever's after ln.
Yes.
Okay.
It's what, if
And
I
then
have
you have
L,
the base on one side and you have the argument on the other side. So you have the base
No.
to the power of x.
base is that number on the bottom of the log, right? Right here we don't have it, but we know that it's E because of the notation ln,
5.
right? So if I have the function y equals ln of x, right?
Okay.
Natural logarithm of x. If I do my xy table, yes, if I enter instead of x I put 5, then my y would be what? Oh, I'm sorry, no, I'm sorry.
So basically ln, it would be e is equal to e to the power of x. Is
Yes.
equal to, okay.
So here my x is e to the power of 5 and my y should be 5. Questions about this? Perfect. Next page. Calculator. Of course, sometimes it's not so easy to calculate, right? We've been dealing with very simple numbers and simple powers. Sometimes it's not possible to evaluate logs by hand. So we will learn how to use calculator. The common log and the natural logs, those commands are available in your calculator. Okay, so whenever you are dealing with just natural or common logs, the calculators will have the button for it, right? The command. So right here in our calculators, here is the log button, we already used it, and here is the ln button. We use them when we graph them, right? But the base is only 10 or e. If you have any other log with any other base but 10 or e, then you have to use this formula that is called the change of base formula. And the formula tells you log base b of m is just common log of m divided by common log of b. Or it actually doesn't matter, this is the same as ln m over ln b. So we are changing the base of log, and so instead of single log, you have division of two logs. The base is the same, either 10 or e, and the arguments are your m and b. So let's practice. The first one, log 25. So log base 10, 25. We don't know how to do this by hand, right? Because if I tried, what would I have? 10 to some kind of power should give me 25. I don't know what that is. It will be decimals, right? So that's why we need calculator. So log 25, right here, log, common log, 25 as an argument, close parenthesis, evaluate. So whenever we use calculator, at least in our class, we will round to the third decimal point. So 3 numbers after the decimal point. That's what we want to do. So right here, what do I have?
1.398.
Okay. Just have it. And the answer is 1.398. Number 2.
You're saying what is the third decimal?
Yes, we want you to round to third decimal. Natural log of 3, again, I don't know how to evaluate this by hand, but I can use calculator. Oops. Natural log, ln, of 3 equals, where's my answer?
Oh my lord.
I know. 1.099. Okay, number 3. Can anyone tell me the answer for number 3 without using calculator? Think about it. I'm trying to figure out the number so that 10 to the power of that number gives me negative 2. Huh? So cannot be, right? Because whatever I choose instead of my question mark, 10 to that power cannot be less than 0, correct? Because if it's really big, like negative 1,000, it will be 1 over 10 to the 1,000. So it's very small, very close to 0, but it will never give me negative. But let's try anyway.
I got
Error?
0.301.
Okay.
Oh,
No,
yeah,
something
you
is
did.
wrong. You did something wrong.
She got
Should be
something.
error.
That's what I got. 0.301.
Did you do negative calculation?
Yeah.
It's like
That's a long
0.01
one.
plus
No,
1.
this one.
That one?
Oh,
It should say 0.301 plus 1.36i.
Oh, what's
Okay, so log negative 2
It's a big
and
number.
then enter.
Yeah,
Well,
that's
why
so
is
big.
it?
What? For me, is it because of the a plus b on?
No, yeah, it's because you have your complex numbers on, so it says I.
Oh, yeah, no. For this, we want you to get error, by the way.
There's an error.
Oh,
Yes, it should be an error. So
Wait.
if you see this I, look closely. If you get complex numbers, right, it means that your
Maybe
calculator
it's
is
the
set
I.
to the complex numbers. And for this lesson, we don't want it. It should be invalid. We are talking the real numbers only here. Okay, right? So if you write this I on the test, that will be error.
Yeah.
But what if you don't tell them? Okay, so questions about this? Yes.
Which
Friday is error or invalid?
Whatever. Invalid.
Not real.
Or yeah, not real is good, but yeah, not real. Error. Okay. So number 4, can I enter this as is into my calculator? No, right? Because the base is 3. My base b is 3. I cannot enter it as is into calculator. So I need to rewrite it using my change of base formula. Log base 3 of 12 is the same as log of 12 over log of 3.
wait, why can't you do that again?
Because the calculator, some of the newer calculators will allow you to enter logs with any base, but our calculators here, the older versions, I guess, I don't know, they don't have, they only have the natural log and the common log.
That's
You
what
cannot choose the base.
mine did it. It went through.
You might, some calculators, I don't know, some calculators could do
So,
this.
I've got
So what I need to do is I need to enter log, natural log of 12 divided by natural log of 3. See what I'm doing? Enter 2.262.
So you can suggest the name, that's not right.
Wait, why would you put divide in? That's
Because that's the formula you have to use. Okay, one second.
not. Isn't that formula that's on the top?
Yes. Yes. See, when I need to calculate the log with base other than 10 or e, earliest number, I'll have to use that formula to convert it. So my answer here would be 2.262.
So, do you mind if I show them a little trick thing that I... So, when... Right? If you're just putting it into the calculator, okay? Just, if I told you guys big font, what do you think?
Big font.
Yeah, if I told you, if I said, a big font, like what would
Big
you...
letters.
Yeah, big letters, right? So if I gave you this and I gave you that, which one has the bigger font
3.
size? Okay, 3 is the bigger font
Oh,
size.
big font over little.
Okay, but what's the small font?
5.
5. Okay, so if it also helps, right? This is very simplified. I tell my students big font over small font, right? Both logs or ln. Whose phone is that? That keeps going off. Turn it off. I'll turn it off for you. Okay.
I heard it's first.
So, here's the fun part though. Guys, this is so good. You ready?
No.
Not that one of our jokes.
I know. This is a good joke.
No. Big yours.
Biggie Smalls. When you go to evaluate, Biggie Smalls. Big font divided by small font. So Biggie Smalls is Notorious B.I.G.
You're killing me, Smalls.
So
Stop trying to be hip.
Biggie Smalls, when you go to evaluate, is log big font divided by log small font, okay? LOG log or LN log, natural log, right? So if it helps you to remember, when you put it into the calculator, please don't get these wrong, right? Just calculator. And you see how 1, 2, and 3, did it have a smalls? Didn't have a smalls, so you could put it straight into the calculator. But if you have a smalls and a big, well then what is this one? Log of, what's my biggie? 13. Divided by log of, what's my smalls?
4.
4. So put that in your calculator. Make
0.63.
sure you close your parentheses after the 13 and
Yes,
after the
ma'am.
4.
Check your answer for number 6. Let me know if it's wrong, different.
That's right.
I know it is.
It's not.
I
Is
know
it
it
there?
is.
Okay. More of the same actually. You can do this on I'm writing my answers here. Check. And if you are done, tell me, did I need calculator for number 9?
No.
No, right? Because I knew that if in my head I'm making this in exponential form or turning this into exponential form, I have e to some kind of power that gives me 1. And anything to the power of 0 is 1, right? It's good if you can recognize it. If not, calculator is also.
Answer from last later.
Okay, questions?
Yes.
Oh, are old investment problems? No, you're not interested?
No.
Not at all. Oh my God, there is nothing that can like get your interest. Okay, so I start with $1. I start with $1. How much do I have after 1 day?
Two.
$2.
$2, right? So multiplied by 2. How much after 3
$4.
days? $4. So 2 times, 1 times 2 to the power of 3, right? Day 1, day 2. After n or x days, how much money do I have?
33 million.
After x days, how much do I have? 2 to the power of what? Come on, guys, think.
2 to the power of 4.
After x days. I didn't tell you. 2 to the power of x. Yes? So I start with $1. After 1 day, I have $2. After two days, I have $4. After 3 days, I have $8, and so on, so on. After x days, I will have 2 to the power of x dollars, right? And I'm told that I have just over $33 million. So let's say this is 33 million. So what is my x? How many days did I keep my money invested in Apple to get $33 million? No. So it's 2 to the power of x equals 33 million. How do I find x? How do I find x? Think about it. Let's rewrite this in log form. What is my base? Base of this exponential function. 2. What is my argument for my log function? $33 million. Equals x. So what is the log with the base of 2 of 33 million? What do I need to use? Change your base formula, yes? So log of 33 million divided by log of 2.
24.99.
About 25 days. Starting with $1, if it doubles every day, only 25 days will give me $33 million. Isn't that exciting? No. So the other question that you can get about these log functions in our class is find the inverse of exponential or find the inverse of log. And by now, hopefully you know that the log is inverse for exponential, exponential is inverse for log, right? So whenever we need to find the inverse, we switch them, argument, and the answer for x and y. We switch x and y. So to find an inverse of exponential function, we convert from exponential to log. If we need to find the inverse of log function, we convert from log to exponential. Right? So we just convert to the other form, and then remember to switch x and y. So let's look at examples. So if you need to find the inverse of this function, right? since I'm starting with exponential, its inverse will be log, correct? The base should stay the same. So what is the base? 2. And then I need to switch argument and the answer, right? So log base of 2 of y equals x. But now I need to remember that I want to switch x and y places. So kind of silly in this one, but just have to do it. And then remember before, we do it still, right? We put the -1 to indicate that this is the inverse of the original. What is it? It wasn't indicated, I'm sure. So -1 to indicate that it's the inverse of my original function. The next one. So my original function is the log function now. So the inverse would be what function?
10
Exponential with what base?
10.
10. Right? Because I don't have the base here, but it's spelled log, log. I know that this is common log, the base is 10. So 10, I need to switch x and y places arguments and answers. So 10 to the power of y should give me x. And now I don't forget to switch x and y places, sorry, kind of silly, and put the negative sign on top to indicate that this is the inverse. And here's the number t. So I'm starting with what kind of function? Right, but is it
ln.
log or exponent?
Log or exponential.
Exponential function is my original one, so I know that inverse will be what? Log, but because the base is e, we spell it ln. And then so natural logarithm of y should give me x. So these two equations are exactly equivalent, right? They represent the same numbers x and y. This is, I'm just changing the form. So now, because I want the inverse function, I need to switch y and x places and put the negative value. Questions? I'm going to write down the answers and then I want to talk about 1 out of 10. Okay, I want to emphasize something. When you have, like in these two examples right here, when your base is fraction, you have to be careful about how you write this, right? The alignment, just like how it looks on the page. Because many of you with this, for this one, you would put something like this. And if your 3/4 is not low enough, to me this looks like common log with the argument 3/4 to the power of x, which is not the same as the log with the base 3/4 of x, right? So instead of doing these parentheses and kind of writing them together, you really have to make sure that your 3/4 is low, like right here. It's in the base of the log, and then x is the argument into the log function, okay? Because it's very hard for us to understand what you wrote, and it will be an error on the test. It's not in your notes, but it doesn't mean that it's not mandatory, Dylan.
What?
The local government projects that the town will grow at a constant rate of 12% per year.
Not my president.
At this rate, how many years will it take that the town population to double? How many years will it take the town population to double? How do we solve this problem? No, we don't. But let's assume. Let's say we have 100 people right now.
That's so fun.
Very small town.
This is so
Yeah.
fun.
So let's say the population at day 0 is 100 people. That's it. What will be the population after 1 year? 100 times what? 1.12%. Will it grow? So multiplied by 1.12. Do we all understand this? Yes? To grow by 12%, I need to multiply 100 by 1.12, right? Or I can also represent it multiplied by 1 plus 0.12, right? Initial and then 12%. So 100 times 1.12. After 2 years, the population will grow to what? The population in the first year multiplied by what? Okay, this is important. This is important, the word problem. So take your eyes up from your computers. Not computers. Your phones, smartphones. So if my population in year 1 is this many people, what will happen between year 1 and year 2?
It will increase.
By how much? Yes, so I need to multiply again by 1.12, right? 12% more. So it will be 100 times 1.12 to the power of 2, correct? After n numbers of years, the population will be what? After n number of years, what is my population if I started with 100 people? 100 times 1.12 to the power of n, correct? That's what you said, right?
7 years.
Yes?
7 years.
7 years.
Hannah, is that what you said?
No, what is it?
You don't understand what I'm doing?
It's fine, go ahead.
No. I need everyone to understand this. You still have time. Okay, let's...
Why is it in plus?
Why isn't it in
Plus.
plus 0.12? Oh, okay. So let's think about this, right? If I start with 100 people today, when the population grows by 12%, 12% of the 100 is 12 people, right? So it's 100 plus 12. That's what you're saying, right? But it's really 100 times 1 plus 0.12 is 100 times 1.12. See?
No, but why is it 100 times n plus
100 plus f plus
times n plus
100 times n plus 0.12.
Why is it?
Okay, let's just think about. Alright.
Is the 1 just for the first one? And then
No.
after that?
1 represents right here, 1 represents 100. 100% plus additional 12%. The 100 that I start with, the 100% is 1, right? And then 0.12 is additional 12%. It's not about number of years, right? So between